All right, welcome back to Sensation and Perception, Part 2C. And let's finish up with taste. We experience four tastes: bitter, sweet, salty, and sour. Now, you may have heard of a fifth category of taste, specifically umami. And there was some evidence for this fifth category, umami, that came out in a paper a couple years ago. But unfortunately, the results of that paper have never really been replicated very satisfactorily. So the jury is still out on whether or not this fifth umami taste really exists. It's supposed to be sort of like what protein tastes like, kind of a meaty type of taste. But anyway, that's why I'm not talking about it, just in case you've heard of it. We're going to focus on bitter, sweet, salty, and sour. So, bitter is usually a red flag that something bad is in the food that we're eating. It's gone bad. It's poisonous somehow. It's rancid. It's not healthy for us to continue eating whatever it is. And the same situation occurs with very sour things. Things that taste very sour, once again, are usually bad for us. It's gone bad, there's poison or rancid in there. Rancid, it's gone rancid somehow. Now, that contrasts with sweet and salty. Sweet and salty are typically indicative of good things. Sweet things are usually high energy. There's a lot of calories in things that are sweet. Back in our evolutionary past, when our sense of taste was developing, calories were very hard to come by. So by making calories taste good, the system is providing motivation to seek out things that taste good, things that have high numbers of calories. And salty is very similar. When things taste salty, they tend to have a lot of sodium in them. Sodium used to be a rare substance for land-based animals to come across. So once again, if you make salt taste good, then there's going to be motivation to seek it out, to consume a lot of it when it's available. Nowadays, it's very easy to acquire calories. It's very easy to acquire sodium. So our evolutionary sense of taste is not really beneficial in modern life. So this begs the question, obviously there's more than just four tastes. How do we taste more than those four tastes? Well, our sense of taste gets combined with our sense of smell. If you've ever had a stuffy nose or experienced a cold and then tried to eat a meal, that meal probably tasted pretty bland. That's because your sense of smell wasn't quite working at the time. So our sense of taste and our sense of smell, they decrease with age. And this is one of the reasons why things seem to taste better as we get older, specifically coffee or beer. I don't know anyone that liked coffee the first time they tried it. I'm sure there's some people out there, but I certainly didn't. Coffee is a very bitter substance. It tastes very bitter. As we get older, we tend to seek out things that have very strong tastes, like coffee, because they don't taste as bitter as they used to when our sense of taste and our sense of smell was much more sensitive. Now let's finish up by talking about synesthesia. Synesthesia is when we perceive one sense as another sense. So you may have seen this in movies or TV shows where the characters are taking drugs, like psychedelic drugs, like magic mushrooms or LSD, and they can see music or taste colors. So that, like the color purple, or the color purple will, you can see the color purple, but it will create a certain taste in your mouth when you see the color purple. Or seeing music, you can see sound waves as they travel through the air. That's kind of how it's portrayed in popular media. And that's not something that's really been studied all that much. But what has been studied is a very different form of synesthesia And this is when we have a specific sensory perception associated with a specific stimulus. So what does that mean? Well, for an example, a specific color will be associated with a specific word or number or letter. So the sensory perception would be the color, and the specific stimulus would be the word, the number, or the letter. And we actually have some verifiable scientific laboratory evidence of this occurring in people, and it might actually be more common than you might guess. So, usually in these types of experiments, people who are experiencing this particular type of synesthesia, they will experience like the color green with the number 5, or the color red with the number 2. And what they'll do is they'll be shown an array of numbers like this, and they'll be asked to find the 2's in an array of 5's. And I'm sure you've been looking at this for a little bit now. You've probably noticed the cluster of 2's in this area down here. But to someone who experiences synesthesia associated with the number 2 or the number 5, they might see something like this. Those number 2's might jump out at them quite a bit more than they do on the left-hand side of the image if you're not experiencing synesthesia. And once again, I will say that we have some verifiable, replicable evidence that this exists, and it's actually quite common, all things considered. So, what in the heck is going on here? Well, the best explanation we have is that during the neural explosion, which is something that happens in our very young years, our very early years, when the brain is still developing every day, we have just this explosive period of growth for the number of neurons in the brain. And we just have that huge, 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 huge increase in the total number of neurons. The brain is basically making connections with everything. And then as we get older, we pare back those connections. We make those connections more efficient. We get rid of the connections that aren't needed, and we strengthen the connections that seem to make the most sense. Now, what might happen is what we have, or what we call cross wiring. And this is when two adjacent parts of the cortex, so two processing areas that are right next to each other, have some communication back and forth that they probably should not have. That's what we refer to as cross wiring. So, in this part of the brain right here, we have the processing center for colors right next to the processing center for graphemes. A grapheme is just a fancy word for letter. So we process letters in this green shaded area, and we process colors in this red shaded area. These processing centers are right next to each other. If there's any cross wiring between those two processing areas, then it's not surprising that you might experience the letter A as blue, or the letter P as green, or something like that. So that's really the best explanation we have at the moment. And that is all I have for the sensation and perception unit. Thank you very much for your attention.